Okay, let's do a revision on IP subnetting using a variable length subnet mask. The first example, 10.1.2.100/24. Okay, so we need to convert this into binary. It looks like this, 10.1.2.100. Okay, /24 will mean that subnet mask will look like this, 24 bits of 1 followed by 8 bits of 0. Okay, so where are the network bits? The network bits are all here, the first 24 bits. So if you want to identify the network address, okay, so for network address, meaning that the network address will be the first 24 bits, okay, will be here, highlighted in red. Okay, how about the host bit? So for network address, the host bit are all set to 0. So the remaining 8 bits are set to 0. This will be your network address. Next, your broadcast address. So your broadcast address is where all the host bits are all set to 1. Okay, so your network bits remains the same, 10.1.2, host bit all set to 1. So this will be your broadcast address. How about your host address? So the host address is all the address between the network and the broadcast. So the first one will be 0.0.0000001. Okay, so this will be your first host address. Okay, the second one will be 0.0000010. Okay, and so on until the last one is 11111110. Okay, so this will be the binary representation. Convert them into decimal. Okay, this is the IP address. This is a subnet mask. This is a host, the network address. Okay, the first host address you can use. Okay, and all the way to the last one that we can use. And the broadcast address will be .255. Okay, so this is VLSM. Okay, the very first example, which is a very simple one, /24. Okay, so again, network address, broadcast address, and the valid host address is the address that's in between. Okay, let's look at the second example. Okay, 10.1.2.100, same IP address. Okay, but we have changed the prefix to /25. Okay, so the IP address remains the same, but because the prefix have been changed to /25, this means that we have 25 bits of 1 here, and then the remaining 7 bits are the host bit. Okay, this means that the first 25 bits here of the IP address are the network address. Okay, so this, okay, you can't touch the red bits because they represent the network. You can touch the host bit. When all the host bits are all equals to 0, okay, this will be the network address. How about the broadcast address? It's when all the host bits equal to 1. But once again, you cannot touch the red bits because they are the network bits. Okay, this is /25. Okay, so I change, but I can change the host bit, and when I change all to be equals to 1, it's a broadcast. Okay, so how about the host address? The host address, okay, again, you can't touch the red one, but you can change the one in black. So the bits that is black, the host bit, you can change it. So this will be the first. This is the second. This is the third host address. Okay, and finally, this is the last one. Okay, convert them back to decimal, you'll get the IP address, the subnet mask. Okay, this will be the network address, okay, the first host address, okay, and so on, okay, until you reach the last host address just before the broadcast address. Okay, so this is the range of host IP address that you can use in this particular network. Okay, time to do another revision question. Okay, so first, given these two IP address, can you tell whether they are in the same network or different network? 10.1.2.100, 10.1.2.200. So are they in the same network or are they in a different network? Okay, the answer is I don't know. Okay, we cannot be sure whether is it in the same network or different network because we need more information. We need to know what is a subnet mask. Okay, now I give you more information, which is the subnet mask or the prefix. So if given is a /24, are they in the same network or different network? The answer is they are in the same network. Why? If you convert them into binary, so now compare these two IP address and the binary format. The first 24 bits, which is over here, all the way here, the first 24 bits are the same between these two IP address. So they are in the same network. They belong to the 10.1.2.0 network. Okay. Okay. If I change the prefix to /25, okay, same IP address, are they in the same network or different network? The answer is no. Okay, this one is a bit more difficult to look at, okay, but if you change them into the binary format, okay, with the subnet mask that looks like this, so now you can obviously see that the first 25 bits, they are different. The first 25 bits are different. Okay, so the difference is in the 25th bit. So because the network bits are different between these two IP address, they are in a different network.